Okay, so today we're going to learn about expected values and standard deviations of discrete events. So if you kind of remember from last time, we worked with tables that kind of look like this and figured out what their distributions would look like. And then since we have distributions, as soon as distributions, we start caring about things like this mean and this, and then how far spread out they are, so these standard deviations. So that's what we're going to kind of look at today and see if we can figure those different things out and figure out like the mean and standard deviations. So there is a formula for this stuff. And the formula for the expected values or the mean kind of makes sense. You take the value that you have and then you times it by its probability. So you take the value that you have and you times it by its probability, and then you add all of them up. And once you add them all up, that would be your mean. So, and this is for discrete events. So for discrete events, we're going to take all our probabilities, we're going to multiply them with our values, and then add them all up. And that should be the expected value we get, or this middle value, this mean. So let's take this one. And if I'm going to find the mean would be 0 times 0.3 plus 1 times 0.4 plus 2 times 0.2 plus 3 times 0.1. And once we add that all up, whatever we get out is going to be our mean. Which, if we do this, we should get 0.4 plus 0.4 plus 0.3, or we will get a value of 1.1. And that's how you find your means. Take your value, times it by your probability, and then add them all up, and that will give you your mean. Again, another name for that is expected value. The expected value we should get, if we do this a lot of times, the expected number of cars everyone should have, or everyone should sell in this case, would be about 1.1. Now let's do the standard deviation. And the nice part is, the standard deviation is calculated pretty much the same way as it's always been calculated. You take your value, you subtract it from your mean, and then you times it by its, then you square it. So we take the value, we subtract it from its mean, and then we square it, just like we've always done. After we do that, we're going to then times it by its probability. So that's the newest thing. Once we do that and add them all up, that's our variance. And how you get from your variance to your standard deviation is you take the square root of that thing. So we're going to try that for this table right here. So, again, we're going to take all our values, and our mean last time was 1.1. So, I'm going to take my value minus 1.1 and times it by 0.3. Oops, that's squared. Plus this value, 1 minus 1.1, square that, and times it by 0.4, plus 2 minus 1.1, square that, and times it by 0.2, plus 3 minus 1.1, square that, and times it by 0.1. Then after we do all of this calculation, we are going to get our variance. And so I've done that ahead of time, and so I'll write down that answer. You get 0.889, and then we would need to take that and square root it. Finish off the 0. So we're going to square root that to find its standard deviation. So this is its variance. and then we'll square root that to get its standard deviation. So its standard deviation would be 0.943. So 0.943. Okay. So that's how you compute its standard deviation and variance. I guess you get its variance off of that, then you take its square root and get standard deviation. Again, this would be the spread, and this would be the mean of my or my expected value. So go through and try some of the problems today, and then see if you can figure the different things out about it.